Hello everyone. Today we will solve the problem LRU cache in lead code. So let's read the problem. We'll have to implement LRU cache where the initialization of LRU cache will be given a capacity, and we'll have to implement two methods, get and put. The get method will return the value for the given key if that key exists, otherwise it will return -1. For the put method, we will be given key and value pair, and we'll have to update the value if the key exists in the cache, otherwise we'll have to add that key value pair into the cache. Another condition is that if the key exceeds the capacity, for this operation, we will have to evict the list recently used. So what is list recently used? It means that for this LRU cache, whenever we perform get or put operation for a particular key, that key will be recently used. And in this way, the key that has been used in the most past, so the earliest accessed key will be the least recently used, and recently used key will have to keep them. So that's LRU cache. And another thing is that we will have to implement this get and put method in constant time. So let's try to understand how we can implement this. So let's say we have a capacity equals to 2. That means that initially we have a empty list of the cache elements, and uh, to track the least recently used and most recently used, we will be ordering this list based on that uses pattern. So let's say head will point to the most recently used, that means the cache element that has been used recently, and tail, this is head, so tail will point to the least recently used. So according to the problem, whenever this list will exceed the capacity, we will have to remove from the tail, and when we put a new key value pair, we will put that in the head of the list, so that because when we put a new element, it will be the most recently used. Okay. So also another thing is that also get operation causes the uses to be recently used. So whenever we perform a get operation, let's say we perform a get operation on a element in the middle somewhere, we will have to move it back to the head so that it will become the most recently used. So that's the way LRU works. Now let's see how we can maintain this ordered list based on the uh, when we have used a key, yeah, that property of LRU cache. So as I have mentioned that we will have head and tail. Head will point to the MRU, most recently used, and tail will be LRU. So for that, we can keep a linked list, and whenever we have to insert, we will insert it into the head, and whenever we will have to remove, when a capacity exceeds, we will remove from the tail. So that's the way we will implement. However, we'll have to keep a mapping of these nodes, because let's say we want to get a middle element, like there are many elements. For example, in this case the capacity will be 5. So for capacity 5, we will have 5 elements, and we want to access this middle element. So in this case, if we don't know the location of this middle element, we'll have to traverse this list, and that will exceed the constant time requirement. So that's why we'll have to keep a map, and that map will be key and node pointer. So the map value will point to a node, another will be, let's say, key 2, it will point to another node. So this way, from this map we can instantly get the uh, target node in this list. Okay, so we'll need to have the map and the node. What we'll have to put a value in this node. Let's say this is a node of this list, so we'll have key value, and we also have to have the pointers to point to the next element and previous element. We have to need we'll have to have both next and previous pointer, because for example, let's say we want to remove this for a get operation, we will have to remove this node. So if we only have the next pointer, then how we will get the previous, we'll be able to update the pointer of the previous one. So by removing, I means this will point to the next, this will be removed. So if we have only one pointer, we'll not be able to do that. But if we had the previous pointer, we easily could access the previous element and then update the next pointer of this previous element. So that's why we will have to need a double linked list. So double linked list and this map will uh, help us to implement this in constant order, constant time. So now let's implement this. So we will have, first of all, we will have a new class for node, and its init function, the constructor, it will have key and value. Also we mentioned that we will have head and tail nodes, that those are just dummy, that will point to the head uh, node and the tail node of this list. So for those node we don't need any key value, that's why we will make it optional. Okay, we'll store this key value, self dot key equals to key, self dot value equals to value, and we will also have next pointer and previous pointer, both points to none initially. So now let's go to the init function of the LRU cache. We have given a capacity, so let's store this capacity for the instance of LRU cache capacity. We will also maintain a size of this LRU cache so that we can detect when capacity exceeds. So size equals to 0 initially, and then we'll have a map, self dot map equals to a empty dictionary, where we will have key and map to the node for that key. Okay, then now we'll have a head pointer, this is a dummy node. We'll have tail pointer, which is also a dummy node, and initially there is no elements, so we'll just point head next to the tail, dot tail, and tail previous element s will be the head, self dot head. So we have initialized all the variables and make a empty linked list, head pointing to tail, tail pointing to head. Now we'll come back to the get function. So for the get function, uh, first condition is that if e exists in the map, then we will have to do something like return that node value. Otherwise we'll have to return -1. So the get operation will updates will remove the node from its current position and uh, add it into the back because into the head, because since we are just accessing this node, it will be recently used, so we will have to uh, move it to the head. So first of all, let's say the node is in self.map with key, and we first need to remove it. So let's say we have remove function, and it will take a node, and then we'll have to insert it in the head. Let's say we have a head insert function that will insert the node in the head of the list. So this function are not implemented yet, so let's have a uh, let's define them. Remove node self and node. We are not implementing it right now, we will just have the structure of those functions. So insert will be, it will take a node and it will insert it into the head. So we'll use them for now and we will implement them at the last. So we have removed the node and then inserted into the uh, head of this list. So now we just return the node value. So that's the implementation of get function. It does two things. One is returning the value of that node if it exists, and removing the node from its current position to the head of the list. So it is most recently used, it becomes. Now we'll go to the put method. We have key and value. So uh, first condition is that if there is this key exists, then we'll have to update it. But even if it exists, we not only have to update it, we will have to move it to the head, because when we perform this put operation, it makes the node most recently used. So we will have to uh, remove it from its current position in the linked list and move it back to the head of the node. So we'll just first remove it, and in the end we'll insert it back. So if E exists in the map, then we will remove it. Self dot remove uh, this node map key. So this node is in the map. The node pointer will be in map of key. Okay, and since we just removed it, we'll have to delete this key from the map. So self dot map key, and also we have to uh, decrement its size. So size will be decremented by 1. Another condition was that if capacity exceeds, we'll also have to remove it. Not this key, but in this case, we will have to remove the least recently used node. Okay, so if our current size is equals to capacity, that means when we insert this key value pair, it will cause uh, uh, it will exceed the capacity of this cache. So we'll have to check that condition and remove that node. So in this case, we'll have to find the least recently used node from the tail. Remember that tail points to the least recently used node. So self dot tail dot previous. Why previous? Because tail is a dummy node and its previous pointer actually points to the actual least recently used node. So we have this LRU node. Now we'll just have to remove it. So remove this LRU, and similarly we have to remove its key from the map. So we'll have to remove it from the map, and then decrement the size by -1. So similar operation. Now that we have removed the capacity LRU when the size is capacity, so in this case we have make a room for the new node. So let's add that new node. So say the new node equals to node with key equals to key and value equals to value, and we just need to insert it. So in the insert in the head. So this new node will be inserted, and we will have to add this in the map. So self.map of key will be this new node, and the size will be incremented at this point because we are inserting a new element in this list. Plus equals to 1. So we can see that there is a pattern. This one and this one gets called when we remove a node, and these two lines gets executed when we add a node. So we can actually just uh, move it in the uh, insert and remove method. So we'll do that when we implement the insert and remove methods. So yeah, that's the implementation of put function. Very straightforward. Just we are translating the problem into the solution. So let's remove the node. Now let's go back to the diagram. So what it means to remove a node. So, okay. So let's say we have this list, and we want to remove this node. So how can we do that? So it's just, let's say this is current, this is previous node, and this is next node. So the previous nodes next will be current dot next. So next equals to just current dot next, current dot next, and this next nodes previous will be yeah, this line means that previous will now point to this next node, and similarly we'll have to update the previous pointer of the next node. So this will point to here. How can we do that? So current dot next, which is actually the next node, and its previous will be current dot previous. Okay, so we don't know what is p, but we can get it by current dot previous. So current dot previous equals to the previous, and its next node will be current next. That means next node. Similarly, this. So when we updated these two pointers, this is not accessible right now, so it will just point to this, so it will not be reachable in this way. Also the next node will point to this p node, that means the c node, current node, will not be reachable. When it is not reachable, Python will just delete it. So yeah, this way a element from a linked list is deleted. So we just do that. So current node is the node, so node dot next, okay, node dot previous dot next will be node dot next, and node dot next dot previous will be node dot previous. So that's the remove operation, and we want to move this uh, function in the remove operation because they are common for all remove operations. So self.map, we would want to delete. Okay, let's uh, do this before the node is not accessible anymore. Okay, it's fine. It's fine because the node is still getting reference, so it will not be removed by Python. So node dot key, so that will be removed from the map and size will be decremented. Okay, so that means we don't need these two lines here. Okay, now we want to insert a node in the head of the list. So let's see how that can be done. So okay, so we have, let's say we have this node and this node, and this is the head is just pointing to this, and this will point back to head. Similarly, there will be two uh yeah, every node has two pointers, next and previous. So now we want to add a new node in front of the current recently used. This is the current recently used, and we want to add in front of it. So head will point here and this will point here. And similarly, current this C node, the current recently used node, will point back to the new node, and new node will point back to the head node. That way, these two links will be removed. That they will be the new list will be like this. So yeah, that's what we want. So how can we do that? So C okay, so head next will be the new node, but currently head next is pointing to the current recently used. So we find the C as head dot next. So we keep this, we separate it first, because if we update the head next, then it will be lost. We will not be able to access it anymore. So we extract it in a new variable, and then we update head dot next equals to the new node. Okay, and new node dot previous will be the head. Okay, similarly, now these two are done here. Now we want to update this these two links. So new node next will be the C node, and C node previous will be the new node. So these four lines are needed to implement the insert function. So let's do that. So current equals to self dot head dot next. Now we want to hit self dot head dot next equals to the new node. Okay, node. So head will now point to the node, and node dot previous will be the head. Okay, similarly we will update the links between current and node. So node dot next will be current, and current dot previous will be the node. And we also seen that whenever we insert a node, we'll have to add it to the map and increment the size. So let's move that here. Self dot map of this key is node dot key. It will be the node, and size will be incremented by 1. So yeah, that's all. Let's run it. Okay, somewhere I have made mistakes. So head, it would be self dot head. Let's find it. Okay, here self dot head. Okay, let's run again. Yes, where is this? Okay, let's check where I have used. Yes. Okay. uh let's check the code. So this node class. Okay, previous typo. Okay, we have this good capacity, size, map, head, tail. Okay, remove node previous, next. Okay, self dot map, size, current is head, next. Okay. Okay. Okay, so when we copied this, we left the s there. So run again. Okay, it is accepted. Let's submit. Okay, it's accepted. So that's all. Leave a comment in the channel. Okay, see you.